ModuMan is a general purpose hydraulic manipulator that our company has developed for nuclear applications. Primarily it's designed for remote handling in the nuclear environment, but it also is suitable for any environments where it's too hazardous for humans to go. We've developed this for a particular application, but we expect to see wide use throughout the nuclear industry. ModuMan's designed to be a very dexterous manipulator with a large range of motion on the joints, and we've designed it specifically that way for the demands of very confined environments. This particular model has a 100 kilogram payload that can extend over a very wide range of motion.
A good way to explain ModuMan is it's very comparable to a human arm. It has 6 degrees of freedom and it has 6 joints that you can move.
For example, we'll have a shoulder joint which will pitch and roll. We'll have elbow joints which will pitch. We'll have the wrist joints which also pitch and roll. 2 of these pitch joints, for example, will travel through 130 degrees either way, which gives this manipulator quite a large range of motion.
ModuMan is driven with 2 3-axis joysticks. These joysticks can be used to drive the manipulator in 3 standard modes. That's joint mode, world mode and tool mode.
A joint mode would be the individual control of each of the manipulator's joints through a joystick controller.
Each axis on the joystick controls an individual joint on the manipulator. The more you move the joystick, the faster that particular joint will move.
In world mode, effectively, that's saying that the operator wants to make the jaws move effectively in the up, down and sideways direction without focusing on the individual movements of the joints.
In world mode, you move the actual end point of the arm, the gripper itself, and you move that through the workspace. You have a multi-joint motion.
And it would be very much like you wishing, for example, to move your hand, not worrying about what the rest of your arm was doing, but just moving your hand in a up, down or sideways direction. So it's very intuitive for the operator. Tool mode makes it intuitively easy for the operator to understand how to manipulate something that would be mounted in the jaws of the manipulator.
In tool mode, you're moving the manipulator based on the orientation of the tool. So if you think of the tool off axis, then as you move through the environment, you can move straight relative to that tool, and every other joint will just fall in place in order to ensure that you keep your orientation and go straight along your path. And you could imagine if you were drilling a hole, then you want to ensure that you want to keep straight to the way that your tool is currently orientated. Another important feature of ModuMan is the ability to record motions of the manipulator. So an operator can actually replay motions they've previously done. The user, or the operator, will provide a name for a path, and from then they can move the arm as they normally would in normal operation and be able to record that motion.
We have a standard gripper jaw here, which would be very common for a manipulator in the nuclear environment. It's designed to take a range of tools and lift a range of objects. The jaw is designed specifically to be removable on the basis that we would expect that item to be subject to damage, and as a result the jaw has a quick remove mechanism which will enable it to be replaced with replacement jaws. But also we could custom design other end fittings if necessary to fit on the end of ModuMan. There are a lot of challenges for designing manipulators for the nuclear industry. It's very difficult in the nuclear environment to maintain and service equipment, so it has to be as reliable and robust as we possibly can make it. So ModuMan is specifically tailored to fit through a standard MSM port. These are common throughout the nuclear industry. So what that means is anywhere that an MSM is deployed in the nuclear industry, our device will go into, and that means that it's got a widespread use and a great number of installations around the world that it would be suitable for. We've used, wherever possible, standard off-the-shelf components. We've tried to use best practice engineering techniques that would give the greatest chance of reliability. We've also managed to keep a large number of components on the clean side, effectively what's known as the outsell area, where if there was an issue, things could be easily serviced and maintained. We think this gives ModuMan the best chance of having a long, trouble-free service life.